Today we're building a SaaS LTV model using SQL logic, one that actually handles the real-world mess with payments and refunds. No basic formulas, no simplifications, and no Excel hacks. Just raw SQL logic that we then will copy into a Google Sheet to make an LTV curve dashboard looking like this. Most tutorials are using an ARPU divided by churn to create or to generate their LTV value. That's pretty dangerous. It assumes that your churn is linear and that your customers' cohorts are behaving the same. I'm going to show you how to build a cohort-based LTV model to aggregate historical payments and calculate the payment age. This is part 1, where I will focus on the data modeling, and in part 2 we will also take the data and do some analysis in a Google Sheet. I've hosted all the SQL code on my Substack. The link is in the description, so feel free to copy that and follow along in the tutorial. We will use 2 different data sets. We have one table which is named SaaS subscriptions, where we have a table with payments and the user ID, a payment date and a payment ID. We also have the amount and a plan type. The second table to use, which we also for sure normally have, is a refunds table, where we have a refund ID connected to a payment ID and the refund date and the amounts that was refunded. We will build this as a CTE, and in the end we will have the data that we will push into a Google Sheet. So first, I want to append the payment and refunds data, like stack them on top of each other. And therefore, I will, from the payments data, we need to make sure that the tables are looking the same. So I will start by making like this, payment date as date, and the amount. These are actually the only 3 tables that I need from exactly this guy. For the refunds, we have to do something similar, but not exactly the same. So you noticed before when we looked at the refunds table, which is pretty normal, that you don't have a user ID in a refunds table. We need to use the payment ID and join that into the table. So here we will use for sure this table. I will actually put it down here. We will use a left join here. And the table we will use will be the refunds table. And we will join on the, no, not the user ID, sorry, but on the payment ID, of course. So here now we can make b.user_id, because we have the user in that table. We have the refund date, and we will name this as a date. And for the amount, for sure we need to take -1 to get like the negative value. So here it will be -1 times amount as I think the name was refund amount, right? Let's see. Refund amount, yeah, so we have refund amount as amount. That's the first step. We've made sure that the tables are using the same columns, and we will be able to append them, like stack them on top of each other. So actually, just let's have a look at how this looks like from appended, the first 1,000 rows, and let's run this and have a quick look. So here we have a user, and let's see if we have any minus values. Yeah, here, for example, the user 1,000 has payments, and then we have this minus value. And why I'm not joining this onto the table is because in real life, the refund date can be later on, but I also want to keep in mind that the discount factor that we will use later on. And therefore, I'm like explicitly using the refund date in the LTV modeling. Let's get rid of this one and move on to the third step. Here we will create, on this appended table, we will take all the columns that we have available, and we will make some helper columns. First of all, we want this date here to be truncated into the monthly value, because we will make the analysis on a monthly basis. So like this. Also, what is needed is that we need the first month for each user. Why is that? Because this is the cohort month when the user starts its LTV journey. And we can get this value with a window function looking like this. So I will take actually the same truncated value. I will copy it in here. So the minimum of this truncated value over partition by user ID, as we will name this to be the cohort month from. Let's have a look at this also actually. So we have these 2 extra months. We are truncating the value onto the monthly value, and also the cohort month will stay the same. So you see here the user 1000 started in October 2023, and we are keeping this value for this user over time, because this helps us later on with some calculations. Now we have made most of the preparation of the data, so now it's time to aggregate it onto a monthly level. This, we need the cohort month. We also need the month of the payment, and then just take the sum as a month from appended cohort group by 1 and 2, and we are done with the monthly aggregation. Another thing that we need, maybe not necessarily, because you could theoretically do it in your dashboarding or something like that, but it's super helpful to also join onto the cohort size so that you have that available on each of the rows. It will help you later on when you're making the analysis in whatever dashboard tool that you're using. And this one is a pretty easy one. It's just select cohort, month, count, distinct, user ID, group by 1. And we will name this cohort size. So now we have this monthly aggregation table. Let's actually have a look at this before moving on from monthly aggregation. And here we will see like the cohort month 1 in the cohort month 1st of January 23. In this first month of this cohort, they were paying this much. In the second month, it's the February, they are paying this much. And it's obviously it goes down a little bit because some of the users are churning, right? What we will do also now is to join on the cohort size to get this into a column here. And also the latest step is that we need the cumulative amount in order to calculate the LTV value also in the dashboard. So let's fix that in the last step. It looks like this. We will use the table's monthly aggr, and we also will join on the cohort size. And here we will take all the columns from table A, from the monthly aggregation table, and we will we will also get the cohort size down here. I also want to add one more table, which is the date diff, because I want to know how many months since start it is for each of the users. So here, for example, the third month, I want a column that says 3 here, 1, 2, 3, etc. Month, a cohort month, so the difference in months between these values. And what we talked about before, the cumulative payments. You see, actually, he suggests that's already BigQuery. Let's make it exactly. So the amount over partition by cohort month, order by month. And With this, we have actually prepared the data exactly as we want it. Let's run this and have a look at the output. The first thing we see is the cohort for the 1st of January 23. You have the months since cohort here, starting by 0 and then goes up. The cumulative payments, which will also increasing over time. And finally, the cohort size. So what we will use then now when we're going into the dashboard is basically just taking this column divided by this column, which will be your growing LTV over time. Let's move into Google Sheets. The first thing we will do is to create a pivot table in here. We can actually start by putting, let's make this a little bit bigger so that you see what I'm doing. Let's start by looking at the cohort sizes. So I'm putting the cohort month in the rows, and as value, I put the value here, cohort size, but I also, as we're having multiple rows per cohort, I also need to set a filter down here and only select the first month. Here we are having the cohort size just for our information, and it seems to range around 2,500 to 3,000 per month. Let's get rid of the totals and let's clean it up a little bit, set a cute date, and we're done. So, but we don't want to get the cohort size. We need the LTV per cohort month. So let's get rid of this one, and instead in the columns we're setting the months since cohort. I will need to get rid of the filter down here also. Now, as we talked about previously, the LTV can be calculated as, we'll make it as a calculated field here. We will take the cumulative payments divided by the cohort size. So what you see here now, when we introduce these two variables in the dataset in the SQL, it's very easy for us to calculate the LTV values. I will just make the formatting a little bit better, get rid of the decimals, and it will be very clear how the LTV is growing. So here, let's look at the first row, cohort 23 January. It's growing first month 53, then 94, 137, etc. And after, for example, 1 year, we are having an LTV at 385. Now, I also want to make a graphical representation of this. Just insert a chart. Don't be afraid of this. It looks nasty, but we will fix this very quick. First of all, we don't want the first row in the data range. We actually will go from the second row. And when you're having this, just scroll down to the bottom, click switch rows and columns, and we are having this cute graph. Sometimes it's a little bit buggy because we want the column A, like this guys here, to be the rows, the colors. And we can normally fix this by just take it back like this. And we're using the A as headers, and here we have a typical LTV curve where each line represents one cohort month, where you can see that, for example, this green line here, it's probably the April 23 cohorts, has the lowest LTV for whatever reason, and this cohort up here, it seems to be maybe May 23. It's a bit hard to see when you're having so many. Is a very good cohort, and you see that also it's not like increasing not increasing linearly, but it's dropping off, which is typically how an LTV curve is looking. I have used SQL to make the heavy lifting in the database, and for the visualization, it's basically just to create the charts, no nasty functions or something like that. In the next video, I will do some further analysis based upon this data, where we will look upon how we can use WACC to discount the money for the future, and also how we can come up with fixed, or not a fixed, but with a value, what we should use as LTV. Hope you liked the video. Give a like. If you have any questions, write it in the comments, and don't forget that the SQL code is also linked down in the description.